Example 1C. Identify the domain and range of the following relation. Write your answer in set notation and interval notation when appropriate. State whether the relation is a function. As with the previous graph, the relation that we see in 1C consists of an infinite number of points. This is represented by the continuous line, the curve if you like. The arrows on the end denote the fact that this curve will continue forever in this direction and forever in that direction. So when we go to identify the domain and range for this specific relation, we want to write our sets in interval notation. That's the way we account for the infinite number of points. So let's begin with our domain. The domain, recall, is the input values, or the x values if you like, that pertain to this relation. Now, as we look at this relation in terms of x values, we want to see how the x-axis corresponds to this graph. Is there an endpoint for the x's? So let's look along the x-axis and notice again, because this curve continues infinitely in this direction, and we're looking for the smallest x value to which the relation applies, we notice that we can continue all the way to negative infinity, following along the graph as we go. This will forever continue, and so the domain will start at negative infinity. That's the smallest, the very, very end. Now, it continues all the way through, and notice our graph is still represented all the way through at all of these x values, and it continues forever in this direction as well, because notice our graph continues this way forever. And so we are going to continue forever. There'll be no stopping point, and thus x will go all the way to positive infinity to the right. So the domain for this specific relation consists of all real numbers, negative infinity to positive infinity. Let's take a look at our range. The range, recall, is your outputs for the relation, your y values if you like. Let's look again at our curve. Notice that this curve here extends forever this direction, extends forever this direction. However, as we're looking along the y-axis to look at the range, notice that there is a value to which the curve does not fall below. We are restricted, we're bounded. The graph doesn't go any farther down here. What is that value? Well, let's count. 1, 2, 3, 4, 5. The lowest number that the relation falls is at -5. That's the smallest point. And the rest are values that are greater than -5. So our relation begins at -5 and then corresponds to all the y values that would go up here. And that continues forever and ever, designated by that arrow going upwards. So we start at -5, but then the relation continues infinitely in the positive direction. So we say that the range of this graph is -5 to infinity. To get the range again, you want to take your graph and kind of take and project or shadow it down to the y-axis to find out what's the smallest value, and then continuing on, notice if you shadowed over, this thing would continue to grow higher and higher and higher and higher and higher along the y-axis, giving us the positive infinity. Now the last question, is this relation a function? In terms of the graph, that means, does this graph satisfy the vertical line test? Well, notice any vertical line that we draw, no matter where it is on this relation, will only pass the graph in one place, in one point. Therefore, this graph does satisfy the vertical line test, and that means that this relation is in fact a function. So the relation is a function. Why? Because it passes the vertical line test. And when it passes the vertical line test, it means that every x value corresponds to one y value. Perfect. That ends example 1C. Let's move on and look at example 1D. This is the last example we're going to do pertaining to graphs. Let's identify the domain and range of the following relation. Then let's write our answer using set notation or interval notation if appropriate. We will then state whether the relation is a function. Notice example 1D is the graph of a circle. It's a relation that contains an infinite number of points along this curve. So when we go to write the domain and range, we're going to use interval notation to describe those sets, since there are an infinite number of points. So the domain is represented along the x-axis. It means what's the smallest x value that pertains to our relation. Well, notice the smallest x value means the lowest place to the left where this curve goes. And notice the smallest place or the farthest place to the left where it goes would be to the value -5 for x. There are no x values any smaller that are represented on this curve. So our domain, we say, starts at the x value of -5 and then proceeds to the right, and what's the largest x value that pertains to this relation? That x value would be this x value here, which is 1. Notice the circle doesn't go any farther to the right of 1. So the domain consists of all the points between -5 and 1 along the x-axis. Let's now look at the range. The range is our outputs or our y values, which we read along the y-axis. The circle, the lowest that it goes in relationship to y, is this value down here, which is -6. The circle doesn't go any lower. So our range starts at -6, and then it goes all the way up, and this is the highest point on our relation in terms of y values. The highest point corresponds here on the y-axis to 0. So we say that our range is from -6 up to 0. We read that, the range, along the y-axis, just as we read the domain along the x-axis. Now let's decide whether this relation is a function. And how do we do that? Well, because the relation is in the form of a graph, we apply the vertical line test. That is, when we draw a vertical line, does it pass through the graph in more than one place? And notice that unfortunately this is not a function, because any vertical line, just about any vertical line that we draw, will pass through the circle in more than one point. So we say that this relation is not a function. And the reason it's not a function is because it fails the vertical line test. Perfect. Let's move on now and let's look at relations and functions in the form of equations.